Alright, good morning everybody. So right now we are looking at what we are going to use as a flow meter in a bore well. Now before looking at what kind of sensor we are going to use, we must look at what kind of applications we need out of that sensor. So when we are looking at a bore well, we are not looking at moderately, we're not looking at laboratory conditions. We're looking at large scale conditions in a farm or in a dam. We're looking at those kind of conditions. So what kind of things we need there? First of all, we need it to be clog resistant. Because whenever you're using it in a farm or whenever you're using water with large amounts of water going through, it's not going to be completely clean. Secondly, we need it to handle a wide flow range, because the flow range will differ with the amount of water that is coming in, and we need our sensor to be able to handle a wide kind of flow range, and also it needs to be compatible with the kind of fluid that we're using. Now thirdly, whenever you're using a bore well, you're using it for a long time. You're not using it for 10 minutes or a day or a couple of months. You're using it for years. So it needs to be low maintenance. It needs to be low maintenance, it needs to be cost effective, and it also needs to have a long life. So you need a robust sensor. Right? We can kind of get an idea what kind of sensor we need to use. We don't need to have a lot of parts in it. We don't need to have a lot of contact with the fluid in it, and we don't need to have a lot of electrical components in it, or very delicate measurement, very delicate adjustments or attachments in it. Because we need a robust sensor that can handle debris, that is cost effective, and also at the same time is accurate. So given the conditions that we have here, we might think of using, say you need a very accurate sensor. You might think of using orifice plates or a venturi meter. But venturi meters and orifice plates are both very sensitive to clog resistance. They're not clog resistance at all, because they use small holes to measure the flow. Secondly, we need it to be compatible with the fluid that we're using. Right? It is not a conductive fluid. We're usually using water. It is not a conductive fluid. So it is difficult for us to use a magnetic flow meter. Another problem with magnetic flow meter is that if your bore well is half filled, you'll see that it gives you a higher reading. Right? So it gives you a higher reading, it's a false reading, we don't want that. Secondly, we also need ease of installation. Now magnetic flow meters, electromagnetic flow meters are very delicate sensors, and they need a very elaborate setup, a very different control, a signal conditioning circuit, you need a monitoring circuit, and it's very difficult to install. Thirdly, we need it to be cost effective, right? So we cannot use Corvallis meter, Corvallis mass meter, or for example vortex shedding. Very expensive sensors, not very useful for a wide range of temperature. So what we need to do is we need to have a robust sensor. So keeping all of this in mind, we might also think of using ultrasonic flow meters. But you see, ultrasonic flow meters have a specific problem that is specific to them, is that the flow of water takes a very long transit time. The signal, the flow of water changes all the time, and the transit time between it changing its flow and it reaching our circuit is very high. So we need something that has a very low circuit transit time, very low information transmission time. It is robust, it is completely compact, right? Because you're using fluids, right? You need to use something that can be used as a stainless, you can use stainless steel in those kind of sensors, that it is robust and it is less corrosive. So given all of this, you can come to a final conclusion that we are going to use a turbine flow meter. A turbine flow meter does not have a direct contact with the fluid. It can handle a very wide range of flows. It is very cheap. It is definitely more accurate than your paddle or your rotameters, right? It is cost effective. And on top of that, it has a very long service life. You can use it for years. If you're using a specific type that is made out of stainless steel, you supply a simple 12 volt DC voltage, and you also have a very low current, like something 30 milliamps or some 30 milliampere or something. So given all of this, given all the applications that we needed, and given the kind of sensors that we have available, the best solution for using a flow meter for a bore well is a turbine type flow meter. Hence our conclusion that we're going to use a turbine type flow meter. Thank you so much.